plug this in and then do this. It's nowhere near as hard as you're currently thinking if you're not trying something. Yeah, it's awesome. The dot product kicks ass when you have vector notation. The dot product is easy, period. I don't have any qualms saying that. Even if you don't think so, you're wrong. I'm a nice guy. Such a sympathetic teacher. It's hard. No, it ain't. You're wrong. It's just a dream. No, it isn't. All right. So when I plug this in, that's A, B, C. Cut to the chase. What is that? What vector is this?
X, Y.
No, the whole thing.
X minus X.
Yeah, X minus X naught. Y minus Y naught. Z minus Z naught. Yeah, so it'll be A, X minus X naught plus B, Y minus Y naught plus Z. Yeah, there's Z. C, Z minus Z naught equals 0. And then what you could do is you get AX plus BY plus CZ equals AX naught plus BY naught plus CZ. Is everybody cool with that? You see that? Just move all that shit to the other side. And sometimes we'll call this is going to be just a number, right? Because X naught, Y naught, Z naught is a given point. They are numbers. So really consider what this means. And you've known this for a while. Do you remember how we interpreted this situation geometrically? Down there. Do you remember this? Do you remember that? Do you remember that? Well, shit. This is a what of what? System of equations, right? And the question would say, solve the system of equations. And you can do it using a matrix, right? But before you learned about matrices, how did you look at this? I'm sorry, what's up? Oh, we just call this D. Just to make the equation... You with me?
Yeah.
Okay, I like it. Just to make it look better. I mean, and now it looks like this. Where 2, we understand 2 would be all this crap worked out. That's where 2 would come from for that. So each of these is a... What's the equation of a plane look like? That's a plane. That's the equation of a plane. How do I know that? Because I started with the definition of a plane, and I worked it out to get here. That's the equation of a plane. Each of these are planes. And I don't know if you remember, but if you were in my class, I said this maybe is this plane, this maybe is that plane, and this maybe is that plane. The solution would be that point. Solutions where they all meet. And that's why it's so easy for these to have no solution, because there's a lot of ways that 3 planes won't agree on one point. Right? Maybe. Okay, so this is familiar. That shouldn't be that big a surprise. You should actually know already that's the equation of a plane. You really sort of should. We didn't make a huge deal out of it, but it was there. What's really, really cool, I want to see who gets this. What is the normal vector to this plane? You can do it. Look at the equation of the plane that we got. Look at the normal vector. Yes, the normal vector to this plane is 1, 1, 1. Because the coefficients are the freaking normal vector components. What the hell? That's so nice. That's too nice. That can't be true, Jeff. Actually, I don't know if you know what nice means, Jeff. This whole thing's shitty. But let this be nice. If you understand the idea behind this, if you understand the idea behind that, all we did was we plugged in the specifics and worked it out. So this is the idea. This is the vector equation of a plane, which by itself, I agree, is not very useful or explanatory. But the idea is there, a normal curve and a given point to find a plane. That idea makes sense. Use the idea to get something that actually looks more practical to use. These things. Maybe. Yes?
Are R and R not given points on the same plane?
R is perfect because it's just X, Y, Z. It doesn't have to be given, it's just there. It's sort of like, does that make sense? I mean,
I think R is your
your general variable. It's given.
You're out.
R naught is the point that you have to be given. Right? So it's sort of like in this equation, do you have to come up with y and x? No, you have to come up with m and b. Y and x are just the variables. They're there all the time. Right? R is the variables. They're there all the time. Holy shit. It's almost time to go. You guys are all spoiled. Stop it. Hold on. Yes?
So, just making sure I understand what the normal vector is on that. So, for the top one, it would be 4 minus 2, 7?
Yes.
Okay.
Is too nice to even believe that that could be true. So, definitely get into 12.5 homework. Anybody who joins Wolfram Alpha, look at 12.6. Look at page 877 in section 12.6. I'm not going to spend a ton of time in section 12.6, by the way. But look at page 877, section 12.6, and just start throwing some of these into Wolfram Alpha and see what the hell happens as you change the numbers. Make some of these yourself. Especially look at the hyperbolic paraboloid. That sounds like a condition you don't want to be told you have, but it's the one that looks like a saddle. It's kind of neat. It's got a saddle point. Alright, that's plenty.
I think Professor Boyko said he emailed you, maybe?
Did you email me?
No.
Oh, about the, yeah, he did. Phil emailed me. I gotta look at it. He emailed me back. I gotta see what he said. Because all I need is